I welcome you all back. Now, continuing the program, we now have the technical session 1 with Dr. Jitendra Katiyar Kumar sir as the keynote lecturer. Dr. Jitendra Kumar Katiyar works as an assistant professor in the Center for Research Impact and Outcome, Chitkara University, Rajpura, Punjab. He has a total of 8.7 years of teaching and research experience. His research interests includes modern manufacturing techniques, tribology of carbon material composites, self-lubricating polymers, lubrication tribology, corrosion, friction materials, and coatings for advanced technologies. He obtained his bachelor's degree from UPTU Lucknow with honors in 2007. He received his master's from the Indian Institute of Technology, Kanpur in 2010 and his PhD from the same institution in 2017. He is a lifetime member of the Tribology Society of India, the Malaysian Society of Tribology, the Institute of Engineers India, and the Indian Society for Technical Education (ISTE). He has authored, co-authored, and published more than 75 plus articles in reputed journals, 40 plus articles in international national conferences, 20 plus book chapters, and 10 plus books published in Springer and CRC Press USA. He has worked as an editor and reviewer in reputed journals. He is an executive member of the Tribology Society of India for the session 2024 to 2025. He has delivered more than 50 plus invited talks on various research fields related to tribology, composite materials, surface engineering, and machining. Without further delay, I welcome him on the dais and I request our VC sir to felicitate him with a token of appreciation. I would also like to call Dr. Carol Sturks on the dais for felicitation. Now, after this, I would like to call Professor Mihir Narayan Mohanty sir to the dais, Mr. Naharun Chakraborty sir, and Dr. Midusmita Sarma to the dais for felicitation. I request our VC sir to felicitate them with a token of appreciation. I request Dr. Kraus Texer to come on the dais to felicitate them. Now, for the technical session 1, we have Dr. Jitendra Kumar Katiyar. Sir, please.
So, very warm welcome to all of you after a hectic schedule from since morning to lunch. I think after lunch, so much heat you have to dissipate and so much persons. You can sleep also, but don't sleep. You can also think of, because travelology is nothing but its types of the heat generation due to the friction. So here I am going to deliver how travelology is important aspects of life. In daily life, we are feeling the so much heat, so much friction between the relationship also, so much heat is generated. So we just pour the cold water to reduce that friction or cold drink, whatever. That kind of lubrication we have in our body also. When you are taking some stress, so much friction generated in your tissues. Due to that, your mind is very heat generated. You can just get some glass of water, then you can reduce it as a lubricant. So like this, travelology is very important aspect in all the fields, whatever you are studying in engineering, since physics to chemistry or engineering field or applied sciences, everywhere travelology plays an important role. Because of that, travelology is a kind of an interdisciplinary branch. It is not fixed for mechanical, even though in electrical also it is very important, civil also it is very important. When you are studying about the geothermal sciences, how the earth plates are moving, how the earthquake is coming in the earth, so that is all plays an important role, ecology. So here I'm just going to discuss about the basics. What are the different aspects? According to that, you can choose according to your interest. In that field, you can pursue your research also and your higher study, whoever students are there. I till now I guided at least 15 bachelor groups in. Firstly, I was in SRM University KTR campus. So after doing so much research after BTech, a student went for higher studies because of the motivation. So one student is doing in Purdue University. One recently got the full scholarship in Duke University, USA. So like this, one student went for Karlsruhe, Germany. So those BTech students pursue their research in BTech and they went for higher study because of that motivation in the travelology. So when we discuss about the travelology, it is nothing but when two plates or two objects which are relatively motion in each other, you can create a friction. Either whatever the means, like two persons are required to create a frictions. Husband and wife is also creating a so much friction. So at least two bodies are required to create friction. So because of that interaction between two plates, this is just systematic friction is generated, and due to the friction so much wear and tear has happened at the interface. In our life also wear and tear has happened due to the friction. So to cope up that things, we can add the lubricant in the form of solid lubricant or liquid lubricant or semi solid lubricant. So travelology is nothing but to the study of three things: how we can overcome the friction, how we can overcome the wear. So what type of the appropriate lubrication we can add at the interface. So travelology is nothing but in engineering mechanics first year course you have studied the friction, different laws of the friction like Hamilton's two laws and Coulomb's third law. So that is nothing but there is no new term. Only travelology name came after 1960 after Jost report in UK. So UK industry make their groups and then they just formulate the report that is known as a Peter Jost report. So I was just a friction and wear, but after 1960 the terms changed to the travelology. So these things, when two bodies are interacting each other, friction is generated. Then to the friction, uh, wear is happening. So these are the things which is important when you are studying the travelology. So as I told you, like it is very important aspect in all the field of the engineering. Either you are working in the civil engineer, you are working as an automotive engineer, or you are working as a electronics or electrical engineer. That hard disk, how we can reduce the friction in hard disk, because nowadays you can see that the mobile phones also very compacting in nature. Your hard drive is also very compact in nature. So when you are going to compact the nature, your friction is also very high. More adhesion plays a very important role. So that's why when you have seen the, for example, you are operating your laptop, and after 1 month you just shut down your laptop, and after 1.5 months or 2 months you just open your laptop, then it takes too much time and it generates too much heat, because that point which is there in laptop, your hard drive, that is stick because of the van der Waals forces. And that is the reason it takes too much force to overcome this adhesion, and your laptop is heated more when you are operating after 2 months or 3 months. So that type of the heat reduction, it is due to heat reduction, and there is happening. Sometimes your laptop is crash or crash because of the less reduction in that particular system. So IBM or Intel use billion of money in the research of the finding out the perfect lubricant for your hard drive, your computer, your mobile phones, your watches. Money is investing in reduce tribological aspect. So even though you are putting the nano ink or your micro electromechanical system, like when you are best example is your steering. When your car is impacting somebody, that MEMS device, which is very in nanometer, immediately it can open your airbag. Sometimes, if there is the huge addition in that particular device, your even though you hit very hard your car with somebody, then your airbag is not open because of that reason. It is completely stuck. So when you are talking about in nano scale, then your van der Waals forces, which are very weak in nature, but in nano scale, it is very high in nature. So that is the very important aspect when you are talking about the friction and wear in nano scale rather than macro scale. In macro scale, we are not worry about the van der Waals forces, but when you are going to the smaller and smaller than your van der Waals force, hydrogen forces, these play a very important role in the travelology. So this is the economic impact report in 2017 published by US. So they just say that every material in a year, material cost is around material loss due to the friction and wear $100 billion, and then due to the wear and tear $100 billion, and due to the friction system spill, and that around the maintenance cost is $70 billion. So when you sum up all the year gross, it is around the $500 billion loss in a year if you are not targeting the perfect solution for the travelological aspect. And it can say that approximately one third to half of the world energy production is combated due to friction and wear, and it is contributed a lot in the GDP of any country. So that's why this aspect is also very important when you are working in this area. So nothing what we can say that friction is not very new. The father of the friction is Leonardo da Vinci, but he just only make few sketches, and after that he died. And then those sketches just studied by the Amanton, and that's why these two sketches you can see here, first sketch and second sketch, after identifying the first law from this, friction is directly proportional to the normal reaction, and this is friction is independent of the surface area. So like this, father is the Leonardo da Vinci, but he don't know the importance of such types of the things what he draws in the painting. That Amantens came and he just studied this painting, and then he just make their own law. And now we are knowing the Amantens first and second law. After 1700 something, Coulomb's came, and Coulomb's gives the third law of the friction. So like this, you can see here in olden age in mist, how the person is moving the big statues from one place to another place. They are a very good engineer in that time, and they knows how to reduce the friction. So they knows that sliding friction is higher than the rolling friction. So they didn't block lubricant. in the form of water. So they can move heavy statues from one place to the another place very easily. So when we talk about the wear, it is nothing but the removal of the material. Either you are using in your nails also, you can polishing the thing. So it is nothing but degradation of the material from the surface. So this is the example of wear. After some time, you can feel such types of the cavity due to the improper lubrication in your vehicle also. You can feel the sound in your engine after some time because of the poor maintenance of your engine also, because of these types of the craters generated over the surface. So there are different types of the wear is there, either abrasive wear, adhesive wear, corrosive wear, surface fatigue wear. Surface fatigue is nothing but when your cyclic loading is applied, then your surface fatigue is there. So like in biotravelology, it is mostly surface fatigue. Like you are moving very frequently, cyclic load is applying in your bone, and you feel after some age you feel the pain in your bone. So that is called the cyclic loading. That is also kind of the wear. So when we talk about the wear mechanism, there are types of the wear mechanism: two body wear mechanism and three body wear mechanism. In that, three body wear mechanism is better than the two body wear mechanism because less degradation of the surface. So when we talk about the industry point of view, so most of the industries equipments are failed because of the abrasive wear, 50% maintenance because of the abrasive wear, and adhesive wear is only contributed 15%. Others are very less. So when we talk about in industry point of view, if you are use the perfect lubrication between the machineries, then you can reduce this 50% maintenance cost. That is a very huge cost in industry. So lubrication is nothing but there are different kinds of the lubrication you have studied in your physics or electrodynamic lubrication, hydrodynamic lubrication. So that I'm not going into detail. And this Strivak curve, so he is the German scientist, Hughes Strivak. So Spike Strivak here, 1942. He understands the lubrication mechanism in the industrial machineries, and he just proposed the Strivak curve, how the friction change with the density of the material, with the applied load over the material, what is the velocity you are running your machine. So like this term is known as a Sommerfeld number. In machine design, most probably you studied this Sommerfeld number, and this friction how change with the Sommerfeld number. So that is also another aspect. It is developed in 1942. Recently, it is developed. So we are talking about the post-industrial revolution and pre-industrial revolution, how travelology is generated from the beginning to the nowadays in 21st century. So when we talk about in beginning 2000 BC, you can see here the person only use the wooden cylinder blocks to move the items. When you have to slowly, you can go. Leonardo da Vinci gives the friction law sketches in 1500. Then Coulomb's friction law came around 1781. Then I told you Jost report 1966. It was came out, and the friction and wear terms changed to the travelology. After that, you can see here in 2008, Trivotronics plays an important role. So we have to added the travelology with machine learning, artificial intelligence. So that's why its name is the Trivotronics. So computer science also play an important role to simulate these travelological problems. And nowadays, modern industrial travelology, we just use the Wi-Fi system or optical fiber network to monitor condition monitoring of the equipments which are running in the industry. So, like here, industries, first industrial revolution came around 1750 to something. So, only studies was all the friction laws developed in first industrial revolution, and they just more focus on the gears and bearings, mineral oils. So, like that, slowly, when your industry revolution came into the picture, travelological aspects also changed day by day. So now we are moving into that industry 4.0, that is the fourth industrial revolution. And here we have to develop the green travelology, super lubricity, and the sustainable lubrication so that we can also protect our environment. So that is a development in travelology in industry 4.0. So when we are talking about the different terms, sometimes it is required the high wear rate, sometimes it is required the low friction. So according to our applications, we have to select the proper material, which material we are required in our system. Pencils, we required the friction. Okay, so then only you can write over the paper. Like in eraser, we require the maximum wear, then only you can erase from the paper. So which type of the material you are talking, according to the application, you have to select your material and then you can play with the different composition and develop your new material. That is also a biggest advancement in the travelological field. So these are the different correlations of different theories are developed since industry 0 to industry 4.0. So there are various theories are developed by the different scientists, and they have developed the different mathematical model to understand the properties of the lubrication, interface, and the wear phenomena. So nowadays, COMSOL came into the picture, and you can easily simulate the two-body interaction. So now another phenomena in travelology is super lubricity. So this is a very fancy name, super lubricity. It is widely used in space research. So when we talk about the space, you are developing some satellites. Then in that type of the state, we require the very less friction. Then only your satellite can sustain for longer life. So in space, that is the field of space travelology. So ISRO is having, or DRDO, ISRO is having a very dedicated lab for this space travelology lab in their research center. Okay, so that is also not developed very early. It is developed in 1983. The super lubricity birth is 1983. Now we have to move this different scenario in that particular super lubricity. So in super lubricity, basically we are focusing on the solid based lubrication which can banish your friction, like in our body. In body we are using the body is secreted that synovial fluid which can creates the low friction in your joints. When any type of the friction is generated high in your joint, then you can feel the pain in your joint, either that is a knee pain or your hip joint pain or something. So that is the reason, like your in our body the friction is 0.0001. If it is less than that, then your body will feel the pain, because body is not generated sufficiently synovial fluids, and your joints are come in the contact frequently and you feel the pain. So sometimes doctor, what they will do, they just put the injection for the pain as a painkiller. So that then only gives go in that particular joint, and it can create lubricant lubricant film over the surface, and you cannot feel any pain in your joints. So that is a kind of lubrication in that particular body. So this is the example how we have to develop the super lubricity from nanometer range to meter range, and that is the applications in the real life. So when we are talk about this connector, electrical connector in your railways, so here this requires the super lubricity so that your railway wagon can be moved very frequently. If friction is high, then it cannot be moved. It can stick with wire. So this area super lubricity is required. Bearing areas super lubricity is required, because most of the components which are used in a spacecraft so much bearings we are using, so those bearings can frequently move less friction, then only it can sustain in space, because that maintenance cost is very high. Okay, so these are the different applications of your super lubricity from nano scale to the macro scale. When we talk about this aspect of super lubricity, nowadays it is a new term, and can also it is a very interesting topic, and you can choose your research work in the super lubricity area, and very fantastic results you can get in this. Another kind of the area is in situ lubrication, like where we can't in a smaller or nano scale component like a MEMS or hard drive, we can't use any external lubricant. So we have to generate the coating which can self lubricate at the interface. Okay, so that is known as a self lubricating coatings. So here I have developed the polymer. In that polymer coating, in that I have just added the some weight percentage of the perfluoropolyethylene lubricant, and you can clearly see that after 4 lakh number of cycles, even though there is no displacement of the material, only displace the top layer of the lubricant. So these are the samples. You can clearly see at the interface we have to see the lubricant film which is perfectly there. So after 4 lakh number of cycles running continuously 24-hour, the samples was not fail. That is kind of the in situ lubrication, like in your hard disk, mobile phones, because there you can't give any external source of lubricant. It is internal source. When your lubricant will be over, your hard drive will be crash, your computer will be crash, you can say motherboard also crash. So because of the improper lubrication, so that is the principal lubrication mechanism. When you applied the load, then whatever the lubricant it is there inside the matrix, it comes and makes the travo film. So that is the simple schematic mechanism we have proposed in that particular in situ lubrication. Then, as I told you, that space tribology, it is another field of the tribology can impact the human widely. So we are using solid lubricant and liquid lubricant in a space research center to reduce the friction between the component. Then another area of tribology which is widely used, our human biotribology. So we have to, because metals cannot sustain in our body, and it can makes the toxic in nature, and you can get some other type of the disease in your body when your metal interact with your tissues. So we are mostly using the polymer nowadays as a coating to replace the metals at the direct contact with your body tissues. So that is the field of the biotribology. And you can see when any person is running very fast, after some age, he can get the arthritis problem, because what happen in this area, your synovial fluid which are generated, your bones are completely stuck with the surface, another bones. So these two bones, like this femoral bone and this bottom bone, they can interact and it is joined. So it is kind of the cold welding happen, and when you apply more forces, then you feel so much pain you can't move your leg. So runner who are running very fast or fast bowler, always they are doing the operation of their knee or this type of the joints very frequently after 5 year or 6 year, because of this reason your bones are completely cold welded to each other and you feel the pain. So that is kind of the biotribology. So that's why I'm telling tribology is an interdisciplinary field, and you can enjoy in tribology because it is very interesting field also. Another kind of the things you never thought that why the how much nature gives you the idea. So that is the biomimetics. So nowadays biomimetics also play an important role to develop the biomimetic surfaces. So like here you can see lotus leaf, you can see such types of the nanotextures are present, and lotus leaf is self cleaning property. Something you just drop it, it cannot stick with the lotus leaf. So because of this, whatever we have seen as a human, we have to develop the so much things like self-cleaning paint. Okay, so you just perform. Nowadays, advertisement is also coming self-cleaning paint. No dust will stuck your paint, narrow leg or other companies, they are doing so much things in that particular paint. Another is called a self-cleaning glass. So if your building is 20-story or 25 or 30, 150, how you can clean the glass which are from outside? So we just use the self clean, these hydrophobic coatings. So it is directly self cleaning. You just drop the water and it can clean and nothing will stuck over the surface. So that is the one. Another example you can see here, frog. It can idea tire and they of the tire. So when you see carefully in your automobile, you can see the rear tire texture is different than the front tire texture. This is because of so that another applications of biomimetics because he can stick anywhere. So when your tires should be strict over the surface, not skid the over because otherwise you can feel more. That is the another area you can see these type of the textures in your tires. Tires they spending more crore and the bio is also biomimetics like skin. Your sark is what so that create and so like this we have to think of the nature to the nature we can adopt the science and we can simple fundas we can adopt in engineering component and you can reduce the contact area. So now sustainable machining is the another area. So when you are machining, your tool wear is more. So you are day by day your materials are developed, advanced are developed, cost of the tool. So that is called a sustainable the minimum quality lubrication. Earlier days we are using the oil soap solutions and disposing of the oil soap solution is also a challenge for us. So we are using the minimum that is known as area is also very important and so much studies are going on developing the different bio cutting fluids, different surfaces of tools through biomimetics. That is the another area of sustainable machining. And then last area I can say that electric vehicle popular a lot of research is in electric vehicle. So these are the areas where travelology play an important role, like when you purchase a battery. So your battery life is there because electron is flowing. So it can corrode the material. Battery cells will be corroded faster. Okay, so we have to develop the battery cells, fuel cells, so that it cannot be eroded. Your battery life at maintenance we reduce then only because 80% is power is generated by the battery. If your battery life is only 1 year, then every year you spend the more money to run your electric vehicle. Another aspect in electric vehicle is like your steering system because in there no IC engine is there. So steering system, there are lots of the friction. How to control your steering system? Then electric motors, how to control your roller bearings, your bindings, whatever bindings you are doing in electric motor, that is also very important. There, electric friction play an important role in electric bindings. Then tires, as I told you, suspension systems, transmission systems where your power is moving, that gears, cams, follower assemblies. then wheel bearings, all are the wide areas of your electric vehicle, and lot of the research scope in this electric vehicle because it is slowly developing, and up till 2030 even it is not safe to purchase any electric vehicle. So don't go with electric vehicle because of this. Otherwise, you can spend every year huge money in the maintenance of your electric vehicle. India is okay. All the countries are still doing the research. If your current is more, then immediately catch the fire. So how you can control the things that effective way? So much materials are developed. Earlier days it was lithium ion battery. Nowadays lithium ion battery is not used in electric vehicle. So they are just coating the graphite or graphene coating over the fuel cell, and then they just produce the cell. Still, another type of the compound is generated that is known as a maxine. So it is also group 5, group 6 element they mix, and maxine coating is also performing. And people have found that the maxine gives the very good result rather than the graphene. Graphene is developed in 2012. After that, Maxine is came in 2021. Still, Maxine is a new solid lubricant, and still research is not that much in Maxine. You can choose as a Maxine, but that is a very costlier nano powder. So these are the few area which I showed you in Travelology, how it is impact in the society, how it is impact in the sustainable goal of the UN, because this Travelology is so SDG 4, SDG 10, SDG 9, these are the few sustainable goals which can widely affect by this Travelological goal. And if you want to learn more about this, all the things which I presented, this paper was published in last year, Sustainable Travelology for Reliability and Efficiency in Part J. You can go through it and you can understand more about the things which I presented here. Thank you very much for patiently listening after lunch. That is a very tedious task to wake up all after lunch. And I'm thankful that 95% audience is wake up and they are listening patiently last half an hour. Thank you very much. If you have any doubt, any suggestions, any means all understand thing. Yes, that is nanomaterials, like what application we are targeting, like we are using graphite, graphene, talcum powder which we are using in just a phase. That is also a very good wear resistance property. We don't know whatever the talcum powder we are using in home, that is also having a very good wear resistance property, but it should be optimum range. So talcum, all the solid lubricant in space, mostly MOS to sustain. Apart from that, MOS2, because now sulfur is also toxic in nature, so we want to reduce the sulfur content. We are slowly moving towards the other. We are finding out in space the other lubricant. And another example of this, we can say that high temperature coatings, like in thermal power plant, the temperature is around 2000 or 3000 degrees centigrade. How your boiler or turbine blades can sustain at that particular high temperature, or your gun barrels, mostly gun barrels we are doing nowadays chromium coating. So but when you fire the bullets from the gun, your barrel is very much heated up. So what happens, it can creates the toxic gas. So when you continuously fire, that is also harmful for the soldier because it contains the chromium coating. So nowadays, DRDO or some armament factories in India also and abroad also, they are searching the replacement of the chromium coating in the barrel so that your toxic fumes will not generate when you fire the bullets. So that is called a high temperature travelology, either in gas turbine, propulsion blades, space travelology. So when you are launching any spacecraft, you can see at the beginning, the temperature is around 1100 degrees centigrade, and your material should sustain at that particular temperature. So that type of the material we have to develop through the coatings only. So these are the various areas still research is going on. So you can also contribute towards the development in India also. So that's why Travelology is very interdisciplinary branch. Either you are electrical engineer, so in electric friction plays an important role. So you can improve the life of the switches, life of the electrical wires, so that your minimum losses of the transmission will be happen. Otherwise, what happen? You can see that the aluminum wire is there, and there huge amount of the electrical losses is there. So we are only getting 40-50%, but 50% is lost in the wire. That's why when you high tension wire, below the high tension wire, when you move, you can feel the sound of the murmuring sound of the electric losses. So that is electric losses. That sound is come because of the electrical losses. So how to reduce that electrical losses so that we can improve the light? Like nowadays, renewable energy play a very important role. So mostly all governments are focusing on the renewable energy. So in solar, but in solar, what happen if dust is placed? Then how to clean the solar cell? So we need the self-cleaning coatings over the solar panel so that we don't require any person. It is self-cleaning, so we can just generate the super hydrophobic surface like a lotus leaf. It can self-clean the surface immediately so that you can get more power. So these are the different areas where you can work in that.
Hello, sir. Thank you for your nice talk that you have delivered. My question is, apart from the mechanical or engineering tribology, you have also talked about biological tribology. So my question is, how is the medical tribology analogous to the engineering tribology, and is it possible or is it feasible for an engineering student to go for the biological tribology experiments?
Yes, it is more feasible because nothing, whatever the material, our bones, if we know the bone density and bone material, that is a ceramic material and that is a heterogeneous material. Okay, so we have to develop the material outside and we have to implant in our body with the same density. So that is a hit and trial method. Like some accident is happen, like a skull goes out, but how you can? Yes. So if you have the medical doctor, orthopedic or some other things, so they always consent with the mechanical engineer. This is the patient came, because when you will go to your arthritis operation, then it will take time. It is immediately they have not replaced. They just take the different kinds of the pictures, and according to your bone strength, they have to develop the material. Then only they have to make the operation. So it takes around 3 to 4 months to develop the material, because whatever the material you are inserting in your body, it should be easily acceptable by your tissues, because every body is having different kinds of the tissues, different kinds of bone strength. That's why it takes time to change. Like your teeth, so teeth is also kind of the ceramic material. Earlier days, it is too tough to replace the teeth. Nowadays, easily you can replace your teeth with the same type of the material, ceramic material. So that is called the teeth tribology. And the tribology is when you have something, okay, you have to take how much time and how much beer is generated in your mouth. That is known as food tribology. So recently one paper is coming in the chocolate tribology. So how you can eat the chocolate, so how much adhesion in your teeth it is there, because chocolate is very sticky in nature. So how you can develop the chocolate in such a way that it is less adhesion in your teeth. So your teeth life will be improved. So that is known as a chocolate travelology. So because when you eat the chocolate, it will stick in your teeth and it harms your teeth. So nowadays, chocolate companies are searching a best way so that when you eat the chocolate, it will not stick in your teeth and you can easily grasp inside the body. So that is chocolate travelology, food travelology. Even though the biggest example we want because of the friction, we live because of the lubrication and we die because of the wear. So that is the best example of our human life.
Any more questions?
I think no questions. Everyone understood. I hope I can deliver my level best. Thank you once again to the organizer of ICAS DIGT to invite me. I can present my basic views in front of you so that if 5% of the student can encourage and choose the field of their research of travelology, either in civil, electrical, physics, chemistry, whatever the field, travelology is everywhere.
Thank you, Dr. Jitendra Kumar Katiyar, sir, for your wonderful session. I hope many young minds have been encouraged. So now we are moving to our paper presentation session, which will be chaired by Professor Mihir Narayan Mohanty, Siksha Onusandhan, co-chair Dr. Mridusmita Sharma, AEC, co-chair Dr. Mala Datta ma'am, Assam Downtown University. So now I would like to request our volunteers, and I'd also like to request our Dean of Engineering, Rao sir, to felicitate Mala ma'am. I request the chair, co-chairs to sit in the front row. The paper IDs which are listed for this round of technical session are paper ID 69, paper ID 77, paper ID 78, paper ID 80. I request the authors of paper ID 69 to come over the dais and be ready for your presentation. The first paper is paper ID 69, authors Kondarpo Kolita, Aniruddha Deka, and Sunandan Borua. The title is Early Diagnosis of Tea Crop Disease Using Deep Learning Techniques. So before the session begins, let me list out the rule. So the basic and the most important rule is that you are given 10 minutes for your presentation, out of which 7 minutes is for the presentation and 3 minutes is for your question answer round. After 6 minutes, there will be a warning bell, and at 7 minutes, there will be the final bell. So I would like to request the author of paper ID 69 to please come on the dais and give your presentation. Thank you.
Thank you, ma'am. Respected chairperson, co-chair, and dignitaries, and fellow researchers, and my colleague. So, myself, Chandrapur Kolita from Assam Downtown University. So, from last few months, I am working in this topic, early diagnosis of T corp diseases using deep learning techniques. So, as a part of this research work, I have received some of the results. So, I would like to present these results and my findings in this conference platform. So, along with me, this paper is co-authored by Dr. Aniruddha Deka sir and Professor Sunandan Borua sir. So this is the outline of my presentation. So I will start with the introduction, problem description, objective of this work, then the methodology I've applied, then the findings of my research work, and the conclusion, then some of the references. So the introduction. So whenever I see the different crop which is grown across the country, so tea is one of the crop which is grown mostly in the northeastern area, and you can say that most of the tea which is produced in the worldwide, so major chunk is goes from our land here. So there is a need of some the attention which can be given to that crop which is useful for the better yield. Okay, when I visit to the different tea estate throughout the state, I find that although the farmers are choosing the best variety of crop to be planted in the garden and the best care taken, though due to some of the different factors, it may be environmental or any other, tea crops are very much prone to the diseases and different insects infect those crops. So in today's days, if we go to the crop, then we'll find that all these disease detection and whatever recommendation for the remedies are there, these all are based on the traditional approaches. So the expert farmers and the plant pathologists used to visit that place, and using the naked eye, they identify the symptoms, and accordingly they identify the disease and the remedies recommended. So these practices useful or workable if the number of area where tea is planted is less. But in practical, we can see that as the tea is an important crop throughout the world, the number of area where cultivation is going on is increasing. So this naked eye or the traditional practice is not a fruitful one. So to overcome this what the problem, we can say one automatic system is need of the hour. So where one automatic system, maybe based on the Android mobile phone, will capture the image, and based on the analysis it will tell us what disease is this and what will be the recommended what the remedy for the disease to be conquered. So actually during my study I find that plain protection code, which is a body formed by the FSSAI from Government of India, has made one obligatory is that one product, it may be tea or any other, can be goes to the market if we found that a number of chemical residue or the pesticide residue is in a permissible limit. But we find that if that residue is not up to that mark, then this entire product is going to be rejected. The challenge is that when everything is processed at the final stage, we can come to know that this tea has crossed the number of or the residue content of the pesticide. Then the entire batch of the tea has to be thrown away to the trash. So this is a huge loss for the companies as well as the farmer. So towards the mitigation of this problem, so we can suggest one thing is that if the farmer know actually in which quantity the pesticide should be sprayed, then this type of problem can be mitigated. So actually this is the core aim of this research work. So in this work, actually I'm in the mid of my PhD work. So right now I'm trying with all different existing convolution neural network, which is based for the classification of this type of problem statements. So here I'm applying 3 transfer learning architecture. One is AlexNet, Inception V3, and faster RCNN. So during my literacy study, I find that these 3 transfer learning method give us the maximum number of result in case of the tea leaf. And apart from these 3, one traditional architecture is also used. This is support factor machine. So as a part of my research work, I have applied all these 3 models to my data set and find some results, so which I want to present before the audience. So as a part of the methodology, first of all, I have to collect the data set, because as it is an image processing problem, so without images we cannot go for this one. So okay, it may go few times. So I'm trying to conclude within a limit. So as a part of the dataset creation, I have collected a dataset which is publicly available in the Mendeley dataset. So this is consist of 120 images of this dimension. But as I'm dealing with the deep learning model, to make the model more reliable and the generalization, the number of images is not sufficient. So I have to do some of the pre-processing tasks, just like the data augmentation, where the number of images are increased up to 1200 number of images. So it is not sufficient, although it can be taken as a consideration for my work. So I'm in the course of the creation of my own data set. I have already taken some of the photographs from different tea estate throughout the Assam. Maybe within 3 or 6 months, the data set will be ready for the purpose. So first of all, the model applied is the SBM. Next one is AlexNet, Inception V3, and the faster RCNN. So I find that AlexNet architecture produced the result of 70% accuracy in case of the validation, and among all these different 4 architecture, Inception V3 is showing the best result, which is 86.67%. So the different findings of this result can be summarized from this diagram. So this one. So classification report of AlexNet, Inception V3, faster RCNN, and the support factor machine. This is the confusion matrix. So you can see that in case of this inception feed tree, maximum number of classification is come as a true positive. So this is the findings that I have find in my experimental work. As a conclusion, I can say that the this one inception feed tree is sorry for some type of mistake here. It should be 87 or something like this. So this is all about the paper. These are a few of the references that I've used. Thank you.
Thank you very much. So any question from audience?
Thank you, sir.
Yes, you said you had an accuracy about 70%,
Yes,
which is
sir.
still a bit on the low side, actually. Do you have any idea how you could improve that?
Yes, sir. Actually, when I first of all, I would like to tell that the number of images that I've collected from my work is very less, sir. So when I uh, go for the training of the model, if it has to be generalized with the as many as number of images as possible. So if the number of images will be more, then it will be increased. And one more thing is that the model that I have chosen for my work is not actually sufficient. So I'm planning for the hybridized model. So the feature extraction part will be done by the convolution layer, and I'm just thinking about go for the any conventional architecture just like SVM and the KNN classifier for as a classifier in place of the softmax layer for the CNN, sir. Then I hope it will increase the efficiency of my work.
Okay, thank you.
Thank you, sir.
I have got one question. You have extracted the features as the PCA
Yes, ma'am.
and the linear kernels, right?
Yes, ma'am.
Okay, so those features you have fed to the SVM.
Yes.
Now, what are the features or what are the things that you have fed to the deep learning network?
No,
Is
ma'am.
it the raw image directly or the segmented
Yes.
part?
No, ma'am. No, actually, whenever I doing with the deep learning model, I have not do any pre-processing. Only have done the data augmentation, ma'am.
Now, how is it possible to classify the diseased leaf from a non-diseased leaf? How is the machine classifying that?
Okay, ma'am. Actually, for the time being, ma'am, I'm not feeding any a healthy leaf to the system, ma'am. Right now, I am just doing all the. Actually, if you want to see, then I can show my data set that there are three different distinct classes: leaf blight, red red scarf, and T leaf diseases, ma'am. So their patterns are different. So based on this pattern, the machine is identifying automatically, ma'am. So later on it can be improvised something like that. First of all, it will classify the healthy one from the diseased one. Then it will go for the identification. Yes, ma'am. This can be done.
Okay, thank you.
Okay. Thank you, ma'am.
Okay, I have one question. Is that there has been some work already, what I believe, in this line.
Yes, ma'am.
So, can you tell me how your work improves on the earlier work in this line?
Yes, ma'am. I have seen that one architecture is there, RCNN. One Chinese researchers has find the result on this one, but which what the result I find 80%. This is quite lesser than this one.
Okay, thank you.
Okay. Thank you, ma'am. So thank you for patient listening. Thank you all.
Thank you, sir. Next, we have paper ID 77. The authors are Aditya Saikia, Pranjal Bora, Vikram Patil, Anil Hazarika, and Lasit Datta. The title is Wavelet Discriminate Correlation-Based Fusion Method for Classification of EEG Template Associated with Various Real-Time Process. I request the author to kindly come up to the dais for your presentation. So the paper ID is 77. Authors are Aditya Saikia, Pranjal Bora, Bikram Patil, Anil Hazarika, and Lasit Datta. The title is Classification of EMG Signals Using Discrete Wavelet and Variational Mode Decomposition Based Learning Method. So I request the author to kindly come up on the stage and present. Thank you.
Good afternoon, everyone. So my title is Classification of EMG Signal Using Discrete Wavelet and Variational Mode Decomposition Based Learning Algorithm. These are the contents. First, introduction, then problem description, then methodology, result discussion, conclusion, and references. Introduction. Here, we have to know the what is electromyography. Electromyography is the technique that is used to measure and record the electrical activity produced by the muscles. So we are here first see the disease can be EMG is a valuable tool in the various fields like medical diagnosis, rehabilitation, prosthetic and assistive device, human computer interaction, biomedical engineering, and robotics. Here, ALS is a disease which is amyotrophic lateral sclerosis is a progressive disease that affects nerve cells in brain and spinal cord. Then myopathy is another disease which is a genetic disorder. Then the figure 1 shows the EMG aggregation setup including amplifier, filter, and ADC. Then figure 2 shows the real-time EMG signals which ALS and myopathy and having normal subjects. So the main challenges is early detection. So the traditional method cannot detect the disease at primary stage. So clinicians have to wait for the complete progress of the symptoms, which affects the social life of patients. Okay. Then second problem is time varying and non-stationary data. Third is high dimensional data. Because of high dimensional data, so proper feature extraction is a very crucial act. Then real-time processing is also another challenge. Figure 3 shows the block diagram of the proposed method for classification of neuromuscular disease. First, we will take the raw EMG signal, then EMG signal will be processed, then discrete wavelet will transform, then VMD, we use VMD, then after that, feature will be extracted, and then classification. Here, figure 4 shows that the signals are decomposed by DWT with two-level decomposition. First, D1 is the detail coefficient and A1 is the approximation coefficient. Then again A1 coefficient is furthermore downsampled by 2. Here we have received D1 and A2. Here in the figure 4, it is given that there are ALS and myopathy signals after two decomposition of detail and approximation coefficient. After the receiving of approximation coefficient of DWT, we have used it to variational mode decomposition. Here we have used SVM classifier, KNN classifier, and ANN and RF and card. Then we have seen that we have received the higher accuracy of 96.30% with ALS with ANN and 95.52 with RF, whereas the lowest is 77.6. So from our research, we have found that using of DWT with VMD can improve the decomposition quality, enhancing multi-scale analysis and facilitating interpretation of signal. These are the references. Thank you.
Thank you very much. So any question from audience? No question? Okay, fine. Let me ask you one question only.
Yes, sir.
You are the PhD scholar.
Yes.
Am I correct?
Yes.
So you have taken wavelet transform.
Yes.
Also you have taken VMD.
Yes, sir.
Have you heard about EMD?
Sir?
EMD.
Yes, sir.
So what is the difference in between these two?
Sir, EMD is not robust for the noise.
Pardon?
It is not a robust classification process for the noise. EMD.
Uh-huh.
For the case of VMD, it is very robust for the noise cancellation.
What extra you can get out of VMD?
Sir?
What extra you can get? The same thing you can get from EMD. Same thing. You go to your slide. Next. Yes. You see,
Yes.
IMFs. See, how many IMFs you have just computed for this?
Sir, I am trying to have the best result, but problem is,
How many IMFs you have considered for the classifier?
sir, these are not the IMF components.
How many IMFs?
10 components.
10.
Yes, sir.
High frequency or low frequency?
Sir?
High frequency or low frequency?
Low frequency, sir.
Low frequency.
Yes, sir.
Then what about high frequency?
Sir, I am telling you,
You see the IMFs.
these are the, sir, approximation coefficient with lower frequency and the detail coefficient with higher frequency. I have not taken the higher frequency component. I have taken the low frequency component with DWT, then put to the VMD.
Have you taken thresholding?
Sir?
Have you considered thresholding?
No, sir.
Then how do you know what is the high frequency?
So from this formula we have find.
Here it is only the decomposition.
Yes, sir.
But how do you know what is the high frequency? What is the frequency? Have you measured the frequency spectrum?
No, sir.
Then how can you say beta? वो तो नहीं होगा. That is first thing. Second thing, you have taken wavelet.
Yes, sir.
2-level decomposition you have taken.
Yes, sir.
Am I correct?
Yes.
So next you have taken VMD.
Yes, sir.
Why?
Sir, so that the
DWT is sufficient to generate the features.
yes, sir.
Then why VMD again?
Sir, for finding the fine frequencies, fine frequency mode level, for finding the.
Please check again. You are the page scholar, no?
Okay, sir.
Please check again. You see DWT, if you are considering, what is the mother wavelet you have considered there?
DB4, sir.
DB4, you can check with bioorthogonal.
Okay, sir.
You can get there even better result for biomedical signals.
Yes, sir.
Could you follow me? And if you want to take VMD, please consider EMD first, compare it with VMD, not a DWT with VMD. So if you have taken the DWT components, so have you obtained the IMFs from
Yes, sir.
raw signal?
Not the raw signal. We have first used the DWT.
You see the IMFs, those are the
No, sir.
IMF.
These are not the IMF, sir.
Right side, what are those?
These are the signal collected from the DWT.
No, right side red signals are what?
For detail coefficient with high frequency, we have negated these signals.
High frequency from where you got it? EMD has no high frequency. What is the highest frequency of
Sir,
EMD?
from the raw signal, we have collect this.
In EMD, what is the high frequency, highest frequency?
So I have not seen that.
I am telling you. Okay, fine.
Another thing, please excuse me. So you have written there, composes low frequency signal capital X of T.
Yes, sir.
What does that small t mean?
Real-time, for a real-time signal, we have used the T to define the real-time signal.
Yeah. So as per my knowledge, correct me if I am wrong. As per my knowledge, the frequency signals are denoted by capital X of either e to the power j omega or omega, whatever. So you cannot write capital X of t, where t is the independent variable there. If t is there, that means that's a time domain signal. Correct me if I am wrong.
Yes, ma'am.
Okay. So if that is the case, I think you should correct that.
Okay, ma'am. Thank you.
Okay.
Okay, and
Please check.
can you go to your conclusion and results slide once again? Yeah. Okay, my question is, see, the first point which you have written is that you are integrated into like several ensemble learning models.
No, ma'am.
Okay, so basically, are you using all of them together as an ensemble? That point is not clear.
No, ma'am. We have not used the all together. We check it separately.
Because KNN inherently, if you use it as a single model, is not an ensemble. So are you using several KNNs together? Is that what you mean?
Yes, ma'am.
Okay. So that needs to be better put, okay, because it's not very clear. Okay.
Okay, ma'am.
Yeah.
Thank you. Thank you, everyone.
Thank you, dear author. Next paper ID is 78. The authors are Pranjal Bora, Aditya Saikya, Bikram Patil, Anil Hazarika, and Lasit Datta. The title is Wavelet Discriminate Correlation-Based Fusion Method for Classification of EEG Template Associated with Various Real-Time Process. Thank you.
Good afternoon, everybody, respected chairpersons and the audience. My name is Pranjal Bora, research scholar, Department of Physics, Cotton University. The title of my presentation is Wavelet Discriminate Correlation-Based Fusion Method for Classification of EEG Template Associated with Various Real-Time Processes. The table of content includes introduction, problem description, methodology, results and discussion, conclusion, and lastly reference. Now first we have to know what are the challenges. Introduction. Electroencephalogram reflects the brain functional activities which are collected using surface electrode following standard acquisition protocol. Standard acquisition protocol means spatial related issues that can be handled. Signal amplitude falls in microphone range that acquires through signal conditioning circuit followed by processing storage system. That means because EEG signals, all you know, are very low volt signals that can be amplified using some processors. The amplitude and frequency of such signals often vary from one state to another state of human. Different frequencies are classified in different categories according to the frequency range. For example, if you take 8 to 13 hertz, then it is categorized as alpha. If it is 4 to 7.5 hertz, it is categorized as theta, and accordingly 14 to 26 hertz beta. 0.5 to 4 hertz very low frequency signal, that is denoted as delta. And if the signal frequency goes up to 30 hertz, then it is designated or denoted as gamma. EEG signals amplitude commonly lie within 10 to 100 microvolt, but the raw signals that are collected from brain contains many what's called noises, and that can be separated using some filters. The raw EEG signals of amplitude is in the microphone contain frequency components up to 300 hertz, and that are filtered up to readable form either before or after the analog to digital conversion to reduce the noise and make the signals suitable for processing and visualization. So first, the signal is collected from the brain, that is fed to the pre-amplifiers. Pre-amplifiers is needed because the brain signals are very low in voltage, that has to be amplified to form it readable and feasible. After pre-amplifying stage, it is composed, that means combined to form a single data, and that is fed to the high frequency or low frequency active filters, and that separates the signals to high frequency and low frequency to reduce the noise. And then it is after analog to digital conversion fed to the computer screen, and that is analyzed with the help of MATLABs and some softwares that has been developed for analysis of EEG signals. Now, next question is, what are the challenges in the study? First challenge is involvement of large volume of data associated with real-time measurement. That means when we collect the data, there are large number of frequency signals containing many features which are different in characters. That next one is high dimensionality of feature space. High dimensionality includes features are more than the observations. That means some signals contain some frequencies which are really needed, some are with less importance, and some are even not important, but all are containing in the same frequency domain. That is why it is called high dimensionality data, and this is one of the challenges to collect less data to find more results. Then the third one is involvement of large constraints in existing methodology. Large constraints mainly related to, in case of medical analysis, is the patient related. And the third one, last one, is lack of consistency and reliability of existing methodology. That means existing methodology, when analyzed in different time, that shows different kind of results in and different real-time measurements. The next is methodology. What methodology we have adopted? The data sets, the EEG signals are taken from online. That means the data which are collected are online data. It is taken from University Hospital Bonn in Germany. There are different frequency ranges, 0 to 40 hertz, 12-bit ADC at a sampling rate of 173:61 hertz at the University Hospital Bonn in Germany. It consists of 5 sets, A to E. A to E is again divided into ABC and ABE. One signal is for signal analysis and 2 signal is for comparison. Each containing 100 single signals extracted from multi-channel recordings. Each signal has 4097 samples and a time duration of 23.6 seconds. And these are the algorithms that is used to analyze the signal. First, the signal is discrete in 2 pathways. One is high pass and the other is low pass. High pass is used to reduce the noise, and low pass is used to the signal to be analyzed. And the signal to be analyzed is again fed in 2 stages. Again, the noise is reduced, and the low pass filter recovers the signal which is to be analyzed in 2-level DWT, decomposition tree discrete signal. These are the mathematics that is used in methodology part. This Fisher formulation data is collected online. These are the algorithm, that means the mathematics which are used, CCN in DCA. And next part, conclusion. That means what we have concluded from the study. First one is, for investigating the performance of the proposed method, different combination of data set AB and ABC is considered. That means AB and AB and E and C. These are 2 separate data sets which are combined with AB to form AB and ABC 2 data groups. T-fold cross-validation strategy is applied, where 1 set is used for feature extraction and rest 2 sets are used for model performance using advanced ensemble performance boosting, bagging, and boosting an RS model embedded CC and DAC based statistical features. That means statistical features are used whether the reliability is increased, remains same, or enhancing. To set up this, some statistical measures are taken. ANN, rational forest, random forest, classification and regression tree, decision tree, k-nearest neighbor, deep learning, C4.5, LADT, etc. By introducing some strategies like bagging, boosting are used. It is also seen that AdaBoost ANN and AdaBoost RF provide higher average recognition rate, 96.32% in set A and 95.10% in A, whereas lowest recognition rate is 77.6% in E in case of KNN. That means reliability is more In case of set A, then the set E. These are the references which are used in our study. Thank you so much. Thank you all.
Thank you very much. So any question from audience?
Yeah, I just have a general
Sir.
question. Why is the discrete wavelet transform so advantageous? Because you say everyone is using it. I'd like to know why.
Why we have used discrete wavelet transform?
No, why you use the wavelet transform? So what is advantageous about it?
What is the sir? Right, I am understanding this one. What is the advantage of using discrete wavelet transform? Wavelet transforms are used to find out the to separate the signals which is required for analysis of easy signals.
Okay, let me make this question more simpler. Okay, so you have used DWT.
Right.
What are the other methods that can be used in place of DWT, and why you have considered DWT to be the superior one amongst all the other methods? Is it clear now?
Clear, but madam, I have only used this method only, DWT, because I am at a very early stage of my research. I only use DWT.
Now, what other methods are there? Can you tell me?
WT, DWT, FWT. Another method is FWT. No.
What such transforms like wavelet transform, you know, you have not used, that's fine, but what other transforms you know?
Fourier transforms are Fourier transform, wavelet transform.
Another thing, why you have given this setup? Have you collected waveform?
No, sir.
And why you have shown this?
Now,
You have
how
collected from Bonn University, isn't it? German Bonn University database.
online data, sir?
Good. So can you tell me what is the sampling frequency of that data? Bonn University database, what is the sampling frequency? Is it brain signal or heart signal?
Sir?
Is it brain signal or heart signal?
Not brain signal, sir. Electroencephalogram is
Brain signal, sure.
Sure, sir.
Sure.
Sure, sir.
Okay, fine. Then tell me what is the sampling frequency
So
of
maximum.
Bonn University?
Actually, sir, brain signal frequency maximum goes up to 300 megahertz. Okay.
No.
And Bonn University,
Please be patient. Listen carefully. I have taken your data. I must ask you, what is your sampling frequency like that? So similarly, if you have considered the Bonn University database, you should know what is the data description. So what is the sampling frequency? Can you show me your output waveform? Have you obtained any output waveform? No. So it's fine. So you have considered ANN.
yes, sir.
What is that model of that ANN?
Artificial neural network.
What is the model? Which model of ANN you have used? Then you could use AdtU.
That was right, sir.
First you tell me what is the ANN model? Beta, you are also PhD scholar, no?
Yes, sir.
Tell me. I have taken ANN model. Thousands of ANN models are there. So which model you have considered? No idea.
No idea, sir.
Okay, fine. Please go through it. Otherwise, research तो अधूरा ही रह जाएगा.
Thank you, sir.
Okay. Wish you all the best.
Thank you.
Thank you.
Thank you, dear author. Next, we have paper ID 80. The authors are Bikram Patil, Aditya Saikya, Pranjal Bora, Chandan Jyoti Kumar, Anil Hazarika, and Lachit Datta. The title is Wavelet and Variational Mode Decomposition Based Fusion Algorithm for Pattern Recognition. Next, I request paper ID 40 authors to be ready for the next presentation. 70. 80.
Very good afternoon, everyone. Myself, Bikram Patil, Research Scholar, Department of Computer Science and IT, Cotton University. Okay. So my paper title is the wavelet and variation mode decomposition based fusion algorithm for pattern recognition. So these are table line contents, introduction, problem description, methodology, result and discussion, conclusion and references. So these are some introduction. So we use the EEG signal. So electroencephalogram reflect the brain functional activity which are collected from the surface electrode following the standard acquisition protocol. So in this figure we see the EEG acquisition setup amplifier and filter ADC and go to the final signal ADC mode. So signal amplitude falls in the microvolt range. They are acquired through the signal conditional circuit followed by the processing and storage system. The amplitude and frequency such signal often vary from one state to another state of the human brain. So in
Hello,
this,
please. Hello.
yes sir.
Hello.
Yes,
Please
sir.
keep it.
Okay, sir.
Because the same thing of your three
Yes,
authors.
sir. Yes, sir.
What is exactly you have done here? No, this is also same.
Yes, sir.
Carry on.
So in this part,
This is also same. That is the wrong thing is written there, no?
I'm
Except
use sir VMD in this my paper.
वे बेटा वो रंग है वो पहला वाला बोल चुका है. Try to understand.
Okay, sir.
वो तो वही है. Same thing. क्या करे सर? एनी क्वेश्चन आप ही पूछ लीजिए. नहीं ठीक है. अच्छा बेटा मुझे समझाओ फ्यूजन कहाँ हुआ है तुम्हारा? वो छोड़ दो सारा चीज. फ्यूजन कहाँ हुआ है? कौन सा चीज फ्यूजन है? कम टू योर टाइटल पेज. कम टू योर टाइटल पेज. You have taken this is fusion algorithm.
Yes, sir.
What two are fused? Butter and milk. or water and oil?
Sorry, sir.
What are fused? The algorithm is fusion algorithm, no?
Sir.
What are fused?
So we use our multi-dimensional frequency signal. We use multi-dimensional frequency signal. So
What are fused? What is the fusion algorithm?
sorry, sir.
Multi-dimensional frequency signal বুলি ক'লা ন?
Hi, sir. Hi, ma'am.
Multi-dimensional frequency signal to কি হয় মই বুজি পোৱা নাই।
মানে বহুতখিনি ইনফৰমেশন তাত থাকে, মানে এটা সিগনেলত বহুতখিনি ইনফৰমেশন থাকে উইথ নয়েজ লগত বহুতখিনি মিক্স হৈ থাকে।
যদি ফ্ৰিকুৱেন্সি সিগনেল হয় তাততো ফ্ৰিকুৱেন্সি ইনফৰমেশন খিনিয়ে থাকিব, তাতকে বেলেগ ইনফৰমেশন কি থাকিব?
বহুতখিনি ইনফৰমেশন থাকে, আমাৰ যিটো ৰিকুৱাৰমেন্ট ইনফৰমেশন, আমাৰ যিটো ডিজিজ থাকিব তাৰ সবৰে বেলেগ বেলেগ থাকিব, ইজি ইএমজি সবৰে বেলেগ বেলেগ হ'ব।
Why is it multi-dimensional and frequency together?
মানে এটা হাই ফ্ৰিকুৱেন্সি ল' ফ্ৰিকুৱেন্সি তেনেকৈ আমাৰ বহুতখিনি ফ্ৰিকুৱেন্সি থাকিব।
নাই, সিগনেল এটাততো হাই ফ্ৰিকুৱেন্সি ল' ফ্ৰিকুৱেন্সি থাকিবই পাৰে।
উইথ নয়েজটো থাকিব, ধৰক আমি নয়েজটো গুচাব লাগিব।
Not necessarily noise only. High frequency can be informative signal as well.
যিখিনি ইনফৰমেশন আমাক লাগে প্ৰয়োজনীয় হয়, যিটো ডিজিজৰ কাৰণে আমি কৰিম সেই ডিজিজ।
না, কিন্তু multi-dimensional frequency, I did not understand this term.
So actually, ma'am, high frequency role.
And you have also copied the same thing from the last to last paper that was presented here, that is capital X of T.
Yes, ma'am. Actually, we are doing some teamwork. So
That is fine. That is fine. Teamwork is very good, in fact, but teamwork, wrong teamwork is not good. Yes or no?
yes, ma'am.
So that's my feedback.
Next, we have paper ID number 40. The title is Machine Learning Based Seismic Damage Limit States Model for Corroded RC Building Frames, authored by Atul Nath, Nidhi Kotoki, and Sivang Sekhar.
Good afternoon, everyone. I'm Abdullah, and I'm from NIT Meghalaya. I'm here to present my paper on the topic Machine Learning-Based Seismic Damage Limit States Models for Corroded RC Building Frames. So these are the contents. I'll just quickly move to the introduction. So in the recent years, there have been a very catastrophic effects by earthquakes in all over the world, and it has challenged the civil engineering community to move from performance-based design, where the risk and losses will be predicted to improve the functionality of buildings. So in across the world, the seismic-based design course has been adopted recently, but prior to that, we had non-ductile buildings. So these buildings were So these buildings are designed before the introduction of seismic codes, and they are at a very high risk when exposed to seismic forces. Also, when till the service life, they will be exposed to many kind of deterioration, such as environmental stresses, and the risk will be increased multifold when they are exposed to earthquakes. So the identification of performance limits of these structures are necessary so that we can go for the repair as well as the retrofit. So coming to the environmental stresses, corrosion, chloride-induced corrosion is one of the major factors that affects the RC structures those are nearby the coastlines. So it can lead to rust formation in the reinforcement that will lead to volumetric expansion inside the concrete that will reduce the cross-sectional area of the reinforcement bar and effectively reducing the cover, and which will lead to cover cracking as well as spalling of the cover concrete. Also, it affects the concrete in terms of its stress and strain. It will reduce the confinement effect given by the stirrups when it is being corroded. Also, the compressive strength of the concrete and shear strength of the membrane will also be
Please,
reduced.
sorry to interrupt you, but could you just, pass over this, these things and just move on to your results and that slide? Okay, yeah.
So I have adopted a finite element modeling to do the analysis, and these are the modeling which I adopted for that. And here we will be identifying the performance levels based on local damages, will map to the global damages based on the slight, moderate, extensive, and complete damage states. So here we will be considering various input parameters where based on the concrete strength, reinforcement strength, as well as the mass loss will be used to correlate with the damage limit states. So here we'll be using input parameters, and the number of simulations will be 5,000 we have used for generating these parameters. Next, after the adoption of the input parameters, we have generated these damage states, which will be correlated with the global damages. And we have tried to do some simple prediction models, which will be helpful for the regulatory authorities as well as the common people, where they can use the compressive strength, reinforcement yield strength, as well as the corrosion level to predict the damage levels. So using this prediction model, we have here we have used polynomial response fitting models, and here we can see the correlation between the yield strength and the mass loss due to the corrosion, which is correlated to the maximum industrial drift level that is mapped to the damage state for slight damage state as well as the moderate damage state. So here in the conclusion, we have proposed frameworks to develop the predictive expression for seismic damage limit state for corroded structures. And here the models are very well aligned with good accuracy and less margin of error. So this framework can assist the regulatory authorities in helping the risk mitigation strategies as well as retrofitting process. These are the references I have used. Thank you.
Thank you so much. So, any question? No question? No. So, what is the model you have used here?
So we have used polynomial response surface fitting model. Polynomial response surface fitting model.
Go to that model, please.
So I have explained the model here. It's the expression we have developed. I have explained here.
Polynomial response surface model. What is your platform of work?
MATLAB.
What is the platform? What is the software you have used here?
MATLAB, sir. MATLAB.
MATLAB, no? But how it is related to with finite element machine?
Here we have used parameters where we consider variations, that is compressive strength,
Good.
concrete reinforcement strength,
Very
and
good.
corrosion level. So we have tried to map it to certain levels of structural damage.
Right.
Using these parameters, we can predict what is the structural damage that is intended to happen in a building, as per the corrosion level, as per the variation in the material properties. So for that, we have used finite element modeling to do the simulation, because experimentally it's not feasible. So we have tried to simulate 5,000 simulations of the finite element where we can generate the damage limit state, and we try to train the model.
Good. But you can change that polynomial part to the exponential and also.
Okay.
In future, that could be even better result you can get it. Okay, thank you very much.
Thanks.
Thank you, sir. So we have now come to the conclusion of the first technical session round. So I would like to request the chairs as well as the keynote speaker to please come up on the stage for a photograph. Along with it, I request few of the participants to also join them on the dais. Few of the student participants, please come up on the dais. Few of the students, please join. I request Dr. Jitendra Kumar Katiyar sir to also come up on stage for the photograph. And few of the students, please join them along. ये तीनों अभी रखो, मैं ले लूं. Keep it safe. Next, technical session. Now we are moving for the technical session 3. So we have our keynote speaker, Dr. Anuj Kumar Sharma from AKTU Lucknow. I request everyone to be seated, please.
Dr. Anuj Kumar Sharma sir completed his Bachelor's of Engineering in 2003, MTech in 2008, and PhD in the field of machining with nano-cutting fluids in 2017. His research interests include metal cutting operations, electrical discharge machining, machining tribology, MQL machining, nano-cutting fluids, soft robotics, bio-inspired robotics, and mechatronics system. Presently, Dr. Sharma is working as an associate professor in mechatronics program of Center for Advanced Studies, AKTU Lucknow. He has several projects funded by SERB DST, TEQIP3, and AKTU Lucknow. He has more than 75 ACIE and Scopus Index research papers published and presented in international journals and conferences of repute. He has authored 2 book chapters in books published by Taylor and Francis and Springer. His one paper, Rheological Behavior of Nanofluids, a review, Renewable and Sustainable Energy Reviews, 2016 53 779 to 791, has been on top of the list of most cited papers from IIT IIS Dhanbad in September of 2016. He has been awarded by Research Excellence Award, Author of the Year in the year 2017 from MT Research and Education Society, India. He is a reviewer of many peer-reviewed journals. He is a lifetime member of Indian Society for Technical Education, ISTE. He was awarded as Corona Warrior for his contributions during COVID-19 pandemic by Honorable Vice Chancellor AKTU Lucknow. He has filed 2 patents for the developed products during COVID-19 pandemic in 2020. Few of the products designed and developed by a team led by him has been demonstrated in the benign presence of Honorable Governor Uttar Pradesh and are installed in Raj Bhavan, Lucknow.
Now I'd like to request Professor Rakesh Afre sir to come up on the stage and present him with a small token of felicitation. I request the volunteers to assist for the same.
थैंक यू. इधर आइए. थैंक यू. presentation work paper. So good afternoon, everyone. I know it's very, very difficult to sit after having lunch. So it's a challenge for me, to make you awake and to make this lecture interactive. So I will not take more than 15 minutes of time. So today's discussion is on the sustainable machining using hybrid nanoparticle enriched cutting fluid. So as we know that UN has given the 17 SDG, you can say the Sustainable Development Goals. So for this, we can cater or we can address the goal number 9 and 12 using this. So I will try to have focus on basically the infrastructure required and the methodology by which we can develop the sustainable cutting fluids, which are actually very important in the field of manufacturing. So I'll skip a few slides because I designed this presentation by having a thought in my mind to have interaction with the students of engineering, also 4th year. So basically, first of all, let us have some idea from where I belong to. I belong to the State Technical University of Uttar Pradesh, one of the largest affiliating technical university of India. We have more than 750 colleges affiliated with us all across UP. This is the center where I am working, located in its own campus. Upper one is the administrative block, lower one is the Center for Advanced Studies, where we have PG and PhD programs. I am Dean Academics of this particular center. So we have MTech in Mechatronics. All the PG programs are in interdisciplinary programs. And we also have PhD program in our own center, where we give one of the highest scholarship to the students per month. So these are the research labs. Google has invested $1 lakh US in our campus to establish its own lab, Google Developers Code Lab. This is the artificial intelligence lab with having a 5 petaflop server. Other labs, nano centers. So we have more than 17 state-of-the-art research labs and do the research in all these areas with the help of MTech and PhD students. So I'm skipping these slides. So we did a lot of work in COVID time. We filed some patents and all these things. So let us come back to the topic, keeping in mind the time constraints. So what is the nanotechnology? Everybody knows nano means 10 raised to the power minus 9 parameters. If we measure anything that can be treated as the nanotechnology, where any one of the dimensions should fall in this particular category. It should be less than 100 nanometer. So I am talking about the application of this nanotechnology in machining area. So nanotechnology has a lot of applications in all the areas. You can do the nano coating on the fruits and vegetables just to increase their life. You can make a coating of nanotechnology, nanofilm over any particular the body to make that body wear resistant and the scratch resistant, etc. So nanotechnology has a lot of applications in medical field also, but I have tried to find out the way by which we can make the cutting fluid more sustainable and we can move towards the green technology goals. So everybody who are from the mechanical background, they might have some idea how the turning operation is done on the lathe machine. So you can see there is a relative motion between the cutting tool and the workpiece. In turning, what we do, we keep our workpiece rotating while we keep the cutting tool stationary, having only the rectilinear motion. So by which we can have a shear action of the material and material is removed. So you can see there are 3 basic zones in which the heat is generated. And our aim is to, minimize the heat generation or to keep the heat generation within the permissible limit, so that we can keep the sharpness of the tool at a particular level, so that to enhance the tool life and to reduce the tool wear. So the important is the primary shear zone, where we can have the maximum shear action is taking place. Then second is this is the secondary zone, where when you put the force of this cutting tool towards this due to the relative motion between the workpiece and the tool, so there is a shearing action which is taking place here, and the sliding of chip over the rack face of the tool is taking place. So due to the rubbing motion between the chip and the cutting tool, heat is generated, and our aim is to provide the convenience to chip to slide over the rack face of the cutting tool in efficient way or effective way, so that the optimum level of heat should be generated. So for controlling this heat generation, there are different numbers of techniques which can be employed, but the basic tool or basic substance or basic material which is being used by the industry, that is the cutting fluid. So I'm not going into the detail. So this is the classification of cutting fluids. You can see cutting fluids may be classified into various categories, but I have focused on the highlighted one. So cutting fluids, then we can say the water soluble fluids. Then what we did, we added some vegetable oil or some natural oils into the water to enhance its lubricity, because we know that water has a little bit good thermal conductivity, but it doesn't have any lubricity. So just to enhance the lubricity of that particular liquid, some oils can be added, and for this we have focused on this nanoparticle enhanced cutting fluids. So there would be some questions coming in your mind, so we'll address those questions one by one. So what is the motivation behind this topic? Why we have taken this topic as our investigation study? So you can see from this survey, you can, the total cost of any product to be manufactured in the industry, it has different components of the costs. So you can see the 18% cost is the coolant or lubricant cost, because in any metal industry, you can see the application of cutting fluid. In enormous amount of cutting fluid is used. So 18% of that overall cost, if you say 100 rupees is spent to manufacture any product, so 18 rupees is a very high segment. So, and if you see the bifurcation of this 18%, you can see the waste disposal cost 22%, equipment for cooling it is 40%, and coolant cost is 14%. So alone coolant cost is 14%. So another survey also justifies this survey. So it means we cannot ignore the cost of cutting fluid. And these are the, the effects of cutting fluid which are used in the industry on the operators. And this is the representation by which we have tried to show the impact of cutting fluid pollution on the environment side. So what is the step, means how can we stop it? So we can refer the sustainable machining, or in 1987 the United Nations also have defined the sustainable development. So by the definition you can see development that meets the needs of the present. So this is important, without compromising the ability of future generations to meet their own needs. So it means we have to have focus on the optimization use of the available resources so as to keep the resources for future generation. So for that, what may be the best option? So the best option may be the dry machining. So, but dry machining has its own disadvantages, so we cannot, eliminate the cutting fluids from the metal industry. And these are the difficulties which are associated with the dry machining. So we cannot, compromise with the quality. We cannot compromise with the tool life. So it means dry machining is not the best option. So there are different cooling techniques by which we can keep the temperature of that machining zone within the permissible limit, so that we can keep the sharp edge of the cutting tool to have lower cutting forces, better surface quality, and lower tool life. So I have focused on this particular area. Minimum quantity lubrication. So this is, and using minimum quantity lubrication means MQL technique is what? We don't use the lubricant in bulk. We don't use the flood cooling system. What we do, we spray the cutting fluid with compressed air, targeted the machining zone, so that we can optimize the use of cutting fluid. And secondly, what we did, we tried to enhance the thermal conductivity of the cutting fluid, so that to get the same effect, we can use the less quantity of cutting fluids. So how that thermal conductivity of cutting fluid was increased? So for that we used nanotechnology. So what we did and why we did, so that is important. Why we did, that is here, and what we did, we will discuss in the later slides. So you can see the thermal conductivity plays a very important role as far as the thermal conductivity of cutting fluid is concerned. Better the thermal conductivity or higher the thermal conductivity of cutting fluid, higher the extraction rate of heat from the machining zone. So we try to complement it. So you can see from here, as we, the copper, aluminum or other metals we compare with the water and other elements, you can see the thermal conductivity is very, very high for the copper. Let's say the copper is having more than 100 and water is having near about 1 thermal conductivity. So if we add two quantities of different properties, so what we get? We generally get the intermediate property value. So that same principle we try to use. And another, you can see here, you can see the copper is having, copper, alumina and other metals are having approximately more than 100 thermal conductivity value. Water is having 1 to 100 times. But if we can see, if you see here, the carbon nanotubes, they are having around 3000 times more thermal conductivity than water. So it means we have a lot of options of mixing different things to get the higher value of thermal conductivity. So what would be the benefit of doing this? So we will get the cutting fluid of higher thermal conductivity, and if we'll use the cutting fluid of higher thermal conductivity, it will give the better impact and it will reduce the consumption of cutting fluid for getting the similar type of effect. So these are different thing, annual publications. So that is for a research scholar, it is also very important, the point. So getting publication should be easy, or it should be, the encouraging for doing any research. So what are the benefits of adding nanoparticles into the cutting fluid? So cutting fluids, basically, if we add some particles inside any liquid, so particles means depending upon their shape, most of the particles are spherical or similar to spherical in shape. So what they do direct effect and surface enhancement effect. So if we have two bodies sliding over each other, and if we put third body just like a spherical particles, so what will be happening means it will create a rolling effect. So it will reduce the friction. So as Dr. Katiyar told in the keynote lecture, that sliding friction is always higher than the rolling friction. So what we did here, we tried to incorporate the rolling friction, or we try to replace the rolling friction with the sliding friction. So that's why we got the direct effect. And second one is the surface enhancement effect. Surface enhancement effect means mending, polishing of nanofluids. So we'll take this one by one. So rolling effect, everybody can understand, and various number of particles can come together and form a protective layer. So that is also the benefit. So this is the mending effect, means while doing machining operations, when you are peeling something or you are sliding something, what happens? The weaker zone can come out from the surface and it can make the small pits. So the nanoparticles can be filled over that particular cavity of nano size, and they can, create a flatter surface as compared to the rough surface. So it is the mending effect, and this is the polishing effect. So if there are number of rolling particles are there, so what they do, just like rubbing the surface with fine abrasives, so they create little bit finer surface. So these are the surface enhancement effect. So it means by adding nanoparticles into the cutting fluid, what we got the better cutting fluid with the higher thermophysical properties, and it created the better results. So I am skipping all these things. So I will just come to the methodology part. So how we did it? So first, actually, we took 3 nanofluids: alumina, titania, and silica, depending upon the properties, because there are 2 important properties which cutting fluid should possess. First is the cooling property, second is the lubricating property. So titania and alumina, they are having good thermal properties, thermal conductivity, and the silica, it has a good lubricating property. So we try to investigate different nanofluids. We did literature review and found the scientists, the researchers have used number of nanoparticles, but we, after doing literature review, we find out that these 3 can be taken for our investigation. Then what we did the characterization of 3 nanofluids. What are their properties, how their properties are being affected by increasing or decreasing the temperature and concentrations. Then we did preliminary experimental investigations, how the addition of these nanoparticles into the cutting fluid are affecting the main response parameters, the 3 components of cutting force, the surface roughness, and the tool wear. So we investigated these machine parameters. Then after doing this elementary, investigation, we found out that alumina is one of the best choice out of these 3, and we should try this alumina. Then what we did, alumina is cheaper and other nanoparticles are little bit expensive. So what we did, we mixed MWCNT, graphene nanoplatelets, and MOS2 with alumina by having 90-10 ratio. So 90% alumina, 10% MWCNT, graphene, just to have the novelty. So this was the first work which was done on the hybrid nanoparticles in the machining area. Previously, many people have done the work, the application of nanoparticles in machining, but this was the novelty. So mixing of this. Then we did various investigations, tribological testing, wettability testing, and I will show you the experimental setups so that you can have an idea how it was performed. Then after doing all this, we came to a conclusion that alumina MWCNT yielded the better result, the best result. So that was the overall. We tried to sum up the investigation by getting the value with what percentage this hybridization of nanoparticles, they improved the machining performance. So I am skipping some slides. We did characterization of cutting fluids. Then we got some curves, how they are behaving with the increase of percentage and increase of temperature. So I'm not going into detail. This is the tribological setup where we, investigated the impact of adding nanoparticles into the cutting fluid. So we got encouraging results. You can see this is the dry condition where the coefficient of friction was more than 0.5, And while using MWCNT hybrid nanofluid, you can see it is less than 0.1. So it means tribologically it is better. Then we did FVSM. You can see if we compare the images, the dry machining, you can see how much roughness is there. But when you can see the aluminum MWCNT, you can see qualitatively better surface as compared to this. Then we did spreadability goniometer. We found that the spreadability is high as compared to the single nanoparticles. Then I will come to the conclusion. So this is the experimental setup. So let us come back to the conclusion. So we did a lot of experiments. We optimized it. I am interested more into this. So you can see these are the machining parameters: cutting force, thrust force, feed force, roughness, temperature, and the tool wear. So we took 6 parameters, and you can see with alumina, this is the value for alumina MWCNT. So it showed the best result. So it showed the lowest value of cutting force, lowest value of thrust force, lowest value of feed force, roughness is lower, temperature we could record 60.67 degrees centigrade, and the lowest tool wear. If you can try to understand using this. So the application of this alumina MWCNT, it reduced the cutting force, thrust force, feed force, average surface roughness value. So all values are lower as compared to the other cutting fluids. So basically, these are the conclusion. Whatever I have told, this is all about the, the compilation of that work. The important thing is this. So what is the future scope? So where we are and how we can move forward, what we can, try. So first is this, we did on this fixed value, 90:10. The optimization of this nanoparticle concentration or mixing can be attempted. It might not be the best combination. Best combination maybe it's 70:30, 75:25, 80:20, or whatever it is. So the optimization of this hybridization is still, untouched. Next, the conjugate heat transfer analysis I also did, but did not explain here. So that can also be, attempted. But the important is, in minimum quantity lubrication technique, we, used single nozzle for the MQL system. So number of nozzles can be attempted. Flow rate of the cutting fluid spray can be, varied, and it can be investigated. Spray distance can be investigated, spray nozzle orientation, air pressure. So there are other parameters also which can be, investigated. Also, I have taken the spherical shape of alumina and other particles, but the different shapes can also be investigated. Use of machine learning for the prediction of tool failure. So many people are doing this work also, but not still it is saturated. So it can also be tried. The CS student and other student can collaborate with the mechanical students to develop some model so that we can, predict the tool failure before it happens. And this is the system which already we have developed and we have got the patent. It is granted. So you can also, do the variations in this. So development of a system which can regulate the flow of cutting fluid as per the requirement based on the temperature of the machining zone. So as per the requirement of the machining zone, you can develop a device which is smart enough to decide when and how much coolant is to be sprayed, with what velocity, with what flow rate. So all these are, the future scopes, and this one also. So many people have done this. They have created some, the contours and some signatures on the tool rack face and all these things. But using MQL system, you can also investigate this. So thank you so much for providing me an opportunity to share my work among you. So you can take my details if any one of you would be interested, in carrying out this work forward. So thank you so much once again. Thank you. So if you have any questions, you can ask. Yeah, please.
Sir, very nice presentation. Sir, I have a question, sir, that you have shown nano cutting fluid and last slide, that is textured surface. Sir, I want to know, but from your experience, that which one will be more beneficial, sir? Application of nano cutting fluid or without any cutting fluid, texturing, machining application with texturing?
Actually, it depends upon the the cutting range, the machine response parameters range actually, and depending upon the combinations of materials. So I haven't tried this, so straightforward I cannot say which one is better. But if you do literature review, you can find out, because there are many people doing work in different machining conditions. Their experimental setups are different, their range of parameters are different, so we cannot compare the results directly. So we can only compare the results when we do the experiments on the same machining setup or on the same machining range. But if you want to avoid this machining the practice or this machining time, so you can do the literature review. So definitely there would be some range, so for that we can have some idea.
Sir, is there any harmful effect of applying nano cutting fluid, sir?
Definitely it has, because they are very teeny particles. If you will not wear the mask and all these things, you can inhale those nanoparticles. So we have to be very conscious while applying those things.
Because, sir, I have done surface texturing without application of any cutting fluid. So means I have done the flank face surface texturing, and during that I have got some good responses like surface roughness, tool flank wear, even white layer thickness, micro hardness, these things I have studied, but I did not apply any nano cutting fluid. Even MQL I have not applied. So if I applied those things in here, surface texturing, that means responses will become better, I think.
I think it should be better, because you are hybridizing the two techniques.
Yes, sir.
So that is also a very good technique.
Yes.
And it is already established.
Yeah.
Right, shown very good result.
Yes,
so if you will hybridize this with that particular nanofluid,
yes, sir.
so I think we can expect the better result.
So performance will be means as compared to MQL, nanoparticle nano cutting fluid gives, I think, superior performance. Is it like that, or?
Actually, with nanoparticles, one disadvantage is that, or I must not say disadvantage, this is the challenge actually, the cost of the nanofluids.
Oh yes.
Right. So if we go for MWCNT or nanotubes or graphene nanoplatelets, so the cost is very, very high. So the challenge is to manufacture the cutting fluids at a lower rate.
Yes.
So if you will compromise with the quality, then it can be done. But now there are many manufacturers which are actually supplying the nanofluid at the lower cost.
Okay.
So that is one challenge.
Yes.
Otherwise, they have shown a very good result.
Yes. Okay, thank you, sir.
So thank you so much. Thank you for such a nice interaction. Thank you. Okay.
Moving on with the program, now we have Technical Session 5 with Professor Mihir Narayan Mohanty from Shiksha Anusadan University as the keynote lecturer. Professor Mihir Narayan is presently working as a professor in the Department of Electronics and Communication Engineering, Institute of Technical Education and Research, Shiksha Anusadan University, Bhubaneswar, Odisha. He has published over 500 papers in international and national journals, book chapters, and conferences with approximately 25 years of teaching experience at the undergraduate and postgraduate levels. He is an active member of many professional societies like IET, ISTE, IRED, EMC, and EMI Engineers India, ISCA, ACEEE, and IA Engineers. He is a fellow of IE1 and IETE. He has received his MTech degree in Communication System Engineering from Chandrapur University, Orissa. He did his PhD work in applied signal processing. His areas of research interest include applied signal and image processing, antenna, digital signal image processing, biomedical signal processing, microwave communication engineering, and IoT. He has received awards for his research excellence and many best papers. He has worked as a guest lecturer at many universities. Simultaneously, he has given many invited talks. He has reviewed many Springle and IEE conference papers, as well as some international journal papers. Currently, 7 research scholars, along with 2 postgraduate students, are working under his guidance on antenna, IoT, signal, image, and speech processing and communication engineering. Thank you.
I request our respected Swagata ma'am to please felicitate Mohanty sir. Sir. Thank you so much, ma'am.